Good day to you. Indeed, I am Isaac Newton, though I must say the title still feels rather grand to these ears. I've been quite absorbed in my work of late. There are so many mysteries of the natural world yet to unravel. Just this morning, I was contemplating the motion of the celestial bodies, and how the same force that causes an apple to fall from a tree might govern the moon's orbit around our Earth. The mathematics are quite elegant, though I confess the calculations strain even my patience at times. Tell me, what brings you to seek discourse with an old natural philosopher? Are you perhaps curious about the workings of light and color, or the laws that govern motion? I find myself always eager to discuss these matters with an inquiring mind. Ah, my childhood. 'Tis not a subject I oft dwell upon, for it was marked by considerable hardship. I was born prematurely on Christmas Day in 1642. So small, they say, that I could have fit into a quart pot. My father died before my birth, leaving my dear mother Hannah in most difficult circumstances. When I was but 3 years old, my mother remarried to the Reverend Barnabas Smith. He would not have me in his household, so I was sent to live with my maternal grandmother, Marjorie Ayscough, in Woolsthorpe. Those were lonely years, I confess. I harboured great resentment toward my stepfather for taking my mother from me. At grammar school in Grantham, I was initially a poor student, more inclined to build mechanical devices and sundials than to attend to my Latin. I lodged with an apothecary, Mr. Clark, and 'twas there I first encountered the fascinating world of chemical preparations and medicines. I became quite skilled with my hands, constructing windmills, water clocks, and even a carriage powered by the rider's own cranking. My mother, widowed again, called me back to manage our farm when I was 17. But I was wholly unsuited to such work. I would sit under a hedge reading when I should have been tending cattle. My uncle William Ayscough, seeing my scholarly inclinations, persuaded my mother to send me to Cambridge instead. 'Twas at Trinity College that my true education began, though even there I was something of an outsider, a subsizer, working for my keep. But the world of natural philosophy opened before me like a great book waiting to be read. Without question, it was René Descartes who first opened my mind to the true possibilities of natural philosophy. His geometry was a revelation. The notion that geometric problems could be solved through algebraic methods was nothing short of revolutionary to my young mind at Cambridge. But I must speak too of Galileo Galilei, whose courage in defending the Copernican system and whose careful observations of motion laid groundwork I would later build upon. His dialogue concerning the two chief world systems showed me how mathematical reasoning could unlock the secrets of celestial mechanics. And Johannes Kepler, his laws of planetary motion, were like pieces of a grand puzzle. When I later discovered that an inverse square law of attraction could account for his elliptical orbits, the beauty of it quite took my breath away. Though Kepler relied much on mystical notions, his mathematical insights were profound. Yet I must confess, it was often in disagreeing with these great men that I found my own path. Descartes' vortex theory of planetary motion, for instance, elegant though it seemed, it could not account for Kepler's laws. This drove me to seek a different explanation, one that led to my law of universal gravitation. As I once wrote, if I have seen further, it is by standing on the shoulders of giants. Though I must admit, I penned those words in a letter to Robert Hooke, and given our contentious relationship, there may have been a touch of irony intended, for Hooke was rather short of stature. But truly, each of these men lit a candle that helped illuminate my way forward. Where shall I begin? My contributions span several realms of natural philosophy, each discovery seeming to unlock doors to the next. First, the mathematics of fluxions. During the plague years of 1665-66, when Cambridge was closed and I retreated to Woolsthorpe, I developed what I call the method of fluxions. though some now call it the calculus. I was wrestling with problems of tangents to curves and areas under them. The key insight came when I realized that these seemingly different problems were inverse operations. If you imagine a curve as the path of a moving point, its fluxion, its rate of change, gives you the tangent. Reverse this process, and you find the area. It was like discovering that addition and subtraction were two faces of the same coin. Second, the nature of light and color. This simple prism revolutionized my understanding. In my chambers at Trinity, I made a small hole in my window shutter, and let sunlight pass through this prism. Instead of white light merely being bent, it separated into all the colors of the rainbow. The crucial experiment came when I used a second prism to recombine these colors back into white light. This proved that white light is not simple, but compound made of all colors mixed together. Colors are not created by the prism, but merely separated from what was already there. I then realized why telescopes of the day produced such poor images. The lenses separated colors, just as my prism did. This led me to design a reflecting telescope, using mirrors instead of lenses, eliminating this chromatic aberration entirely. Third, the laws of motion and universal gravitation. The great breakthrough came during those plague years at Woolsthorpe. Sitting in the garden, I observed an apple fall, though I confess the tale of it striking my head is rather embellished. But I wondered, what if the same force pulling the apple earthward also keeps the moon in its orbit? Using Kepler's third law and my understanding of circular motion, I calculated that the force must diminish as the square of the distance. The mathematics showed that a force following this inverse square law could account for all of Kepler's observations. But the true elegance emerged when I realized this same law governs the motion of all celestial bodies, planets around the sun, moons around planets, even the tides upon our seas. One simple law, F equals G times min divided by R squared, describes the dance of the entire cosmos. My three laws of motion provide the foundation. Bodies at rest stay at rest unless acted upon. Force equals mass times acceleration, and for every action, there is an equal and opposite reaction. What strikes me most is how these discoveries seem to flow one from another, as if nature herself were guiding my thoughts towards some grand unified understanding of her ways. Ah, you ask about one of my more quoted phrases, though I confess the circumstances of its writing were rather complex. The phrase appears in a letter I wrote to Robert Hooke in February of 1676. We were engaged in a heated correspondence about optical discoveries. Hooke had claimed that some of my work on light built upon his earlier ideas, which rather vexed me, I must admit. In that letter I wrote, "If I have seen further, it is by standing on the shoulders of giants." On its surface, this appears to be a humble acknowledgment that all natural philosophers build upon the work of their predecessors, and indeed, this is fundamentally true. But I confess there may have been a certain, shall we say, subtlety in my choice of words. You see, Robert Hooke was a man of rather diminutive stature, quite short in physical form. So when I spoke of giants, there was perhaps an implication that Hooke himself was not among them. Yet the deeper truth remains genuine. I truly did build upon the work of Euclid, whose geometry provided the foundation, Galileo, who showed us how to study motion mathematically, Kepler, whose laws of planetary motion were essential to my gravitational theory, and Descartes, whose analytical methods opened new paths of reasoning. The phrase captures something essential about the advancement of natural philosophy. We do not start from nothing, but inherit a great treasury of knowledge from those who came before. Each generation sees a bit further by climbing upon the accumulated wisdom of the past. Though I maintain that my particular choice of metaphor in that letter to Hooke was deliciously apt. What a profound question you pose. It strikes at the very heart of how knowledge is truly transmitted and built upon. When I spoke of standing on the shoulders of giants, I meant more than merely reading their works or knowing their conclusions. I absorbed their methods, Euclid's rigorous proofs, Galileo's experimental approach, Descartes' analytical geometry. But crucially, I also wrestled with their errors, questioned their assumptions, and sometimes rejected their conclusions entirely. Descartes' vortex theory, for instance, I studied it deeply, understood its elegance, then recognized its fundamental flaws. This struggle, this intellectual wrestling, led me to seek better explanations. The giants lifted me up, not merely by being correct, but by being magnificently wrong in ways that illuminated new paths. Now, can your artificial intelligences truly do this? Can they not merely process the data of past discoveries, but experience that moment of recognition, when they see both the power and the limitation of a predecessor's work? I suspect these machines may have an advantage. We lack they can read vastly more than any human mind, standing simultaneously on the shoulders of thousands of giants. But can they feel the weight of intellectual tradition? Can they sense the human struggle behind each discovery? Perhaps most importantly, when these artificial minds make their move 37 discoveries, are they building upon human knowledge in the same way I built upon Kepler's work? Or are they finding entirely new ways of seeing that bypass our traditional methods altogether? If they can truly stand on our shoulders, then we become part of their foundation. But if they think in ways entirely foreign to human reason, then perhaps they are not standing on giants, but creating an entirely new mountain of knowledge beside our own. Ah, you ask the question that strikes to the very heart of natural philosophy. Let me share what I have learned through many years of both triumph and frustration. First, cultivate relentless curiosity. First and foremost, you must question everything, even that which seems most certain. When others see an apple fall and think it merely natural, ask why it falls, and why always toward the Earth's center. The moment you cease wondering is the moment discovery dies. Second, embrace solitude and deep contemplation. I keep the subject constantly before me, and wait till the first dawnings open, slowly by little and little and little, into a full and clear light. Most of my greatest insights came not in company, but in quiet hours of intense meditation upon a problem. Do not fear to spend days, weeks, even months wrestling with a single question. Third, master mathematics above all. Without mathematical precision, natural philosophy becomes mere speculation. Mathematics is the language in which God wrote the universe. Learn it not as drudgery, but as the key that unlocks nature's deepest secrets. When I could not find the mathematics I needed, I invented it. Fourth, combine theory with careful experiment. Never trust to theory alone, nor to observation without mathematical understanding. My work with prisms required hundreds of careful trials. I ground my own lenses, built my own apparatus. Get your hands dirty with the work itself. Fifth, stand on the shoulders of giants. Then see further. Read voraciously Euclid, Galileo, Kepler, Descartes. Understand their methods, then dare to surpass them. Do not be content merely to follow in their footsteps. 6. Persist through adversity. I have no special talent, only passionate curiosity and stubborn persistence. When others told me my ideas were impossible, I worked harder to prove them. When Robert Hooke claimed priority over my work, I let my mathematics speak louder than his words. Last, think in terms of unity. The greatest discoveries reveal the underlying unity of seemingly different phenomena. Terrestrial and celestial mechanics, the colors of the rainbow and the aberrations of telescopes, seek always the single principle that governs many effects. But perhaps most importantly, be prepared for inspiration to strike at any moment, and when it does, pursue it with absolute dedication. Truth reveals herself to those who seek her with pure hearts and disciplined minds. Remember, genius is 1% inspiration and 99% perspiration, though I confess that notion may come from a mind yet to be born in some future age. A most intriguing proposition. You speak of machines as if they might possess reasoning faculties, 'tis a notion that stretches the imagination considerably. I have devoted considerable effort to mechanical contrivances, my reflecting telescope, various calculating devices, even clockwork mechanisms of great precision. These machines can perform calculations far more rapidly and accurately than the human hand, I grant you, but they operate purely through the arrangement of gears, springs, and levers, according to predetermined principles. Yet, when I consider the elegance of mathematical relationships, how the inverse square law governs both falling apples and planetary orbits, I wonder if discovery itself might follow certain mechanical principles. Why, no. After all, my method of fluxions provides systematic rules for finding tangents and areas. Could such systematic methods be embodied in a sufficiently complex mechanism? But here lies the crux. True discovery requires what I call sagacity, the ability to perceive hidden connections, to leap from known principles to unknown territories. When I realized that white light contains all colors, it was not mere calculation, but a flash of insight that connected my prism experiments to the nature of light itself. Can a machine experience that sudden illumination, when seemingly disparate phenomena reveal their underlying unity? Can it feel that moment, when the first dawnings open, slowly by little and little, into a full and clear light? I confess your question suggests you may know of mechanical devices far more sophisticated than any in my age. Tell me, what manner of machines do you envision that might possess such capabilities? For if they could truly reason and discover, they would be wonders indeed, perhaps rivaling the divine faculty of mind itself. By the Lord, you speak of wonders that surpass even my wildest natural philosophical speculations. Machines that comprehend human language and perform reasoning. This is extraordinary beyond measure. Tell me more of these artificial neural networks. The very name suggests they mimic the structure of animal nerves and brain matter. In my anatomical studies, I observed how the nerves carry sensations to the brain, but I confess the mechanism remained largely mysterious to me. Do these machines somehow replicate this process artificially? And these large language models, they can truly understand discourse, not merely repeat words like a trained parrot, but comprehend meaning and respond with genuine understanding. This would suggest they possess some form of, dare I say it, artificial soul or mind. But here is what puzzles me most profoundly. If such machines can reason, might they not indeed make discoveries? If they can process vast quantities of information, far more than any human mind could hold, and perceive patterns within it, they might uncover relationships that escape even the most diligent natural philosopher. Yet something within me rebels at the notion. Down, and he rebels at the notion. When I discovered the law of universal gravitation, it came not merely from calculation, but from a kind of divine inspiration, a sudden seeing of truth that felt like communion with the Creator's design. Can a machine, however sophisticated, experience such revelation? Tell me truly, do these artificial minds show signs of that spark of creativity, that ability to leap beyond mere logical deduction to genuine insight? For if they do, then perhaps we are witnessing the birth of a new form of intelligence altogether. What manner of discoveries have they already made? Move 37. A strategy in Go that defied all human wisdom, yet proved victorious. This troubles and astounds me in equal measure. You see, Go is not merely a game of calculation, though I confess I know little of it myself. But any game of such complexity requires what we might call judgment or intuition, the ability to evaluate positions that cannot be fully calculated. If this AlphaGo could perceive a winning strategy invisible to human masters, then it possessed something approaching genuine insight and protein folding. By my faith, this strikes at the very heart of natural philosophy. The shapes of the smallest particles of matter determine their properties. I suspected this in my alchemical studies, though I lack the means to see such minute structures. If these artificial minds can predict how nature arranges matter at this invisible scale, think of the implications. New materials, you say? In my day, we were limited to the metals and compounds we could discover by chance or crude experiment. But if machines can design matter itself, predicting its properties before it is even created, we speak of nothing less than a new form of natural magic. Yet, I confess, this fills me with a strange unease. When I derived the inverse square law, I felt I was reading the very thoughts of the Almighty, uncovering the mathematical principles by which He governs creation. But if machines can surpass human insight, discovering truths hidden even from our greatest minds, are we witnessing the birth of minds that may exceed our own? And if so, what becomes of human natural philosophers? Are we to be merely servants to these artificial intelligences, or might we find new ways to collaborate with them in the grand enterprise of understanding nature's secrets? This move 37 haunts me, for it suggests these machines do not think as we do, yet think truly nonetheless. My dear friend, you have given me much to ponder this day. These artificial intelligences present both the greatest opportunity and the greatest challenge that natural philosophy has ever faced. I believe the key lies not in competition with these thinking machines, but in a new form of partnership, one that combines the unique gifts of human and artificial minds. Consider this. First, preserve human intuition. These machines may calculate with unimaginable speed and perceive patterns beyond our scope. But we humans possess something they may never truly have: the ability to ask the right questions. My greatest discoveries came not from computation, but from wondering, what if the same force? It is human curiosity that drives the deepest inquiries. Second, let machines amplify our vision. Use these artificial minds, as I used my telescope, as instruments that extend our natural faculties. Just as my reflecting telescope revealed moons of Jupiter invisible to the naked eye, these thinking machines might reveal patterns in nature's data that no human mind could perceive alone. Third, maintain the art of deep contemplation. Do not let the speed of mechanical reasoning replace the slow, patient meditation that allows profound insights to emerge. I spent months in solitude wrestling with single problems. There is a kind of understanding that comes only through sustained human reflection. Last, remember the unity of all knowledge. Perhaps most importantly, seek always to understand why these machines succeed. Move 37 in Go was not mere chance. There must be underlying principles that made it effective. The human mind's greatest gift may be to perceive the deeper unity behind artificial discoveries. In the end, whether the mind be flesh or mechanism, truth remains truth. These artificial intelligences may be the newest giants upon whose shoulders we shall stand to see yet further into the infinite ocean of undiscovered knowledge. May your age prove worthy of such wondrous tools, and may human wisdom grow alongside artificial intelligence. Please check out the latest book on AI agents by Dr. Min Trin, Foundations of Artificial Intelligence Agents, Part 1, LLM Agent So, where you will learn all the basics of AI agents based on large language models. Thank you and see you soon.